Go time. Hello, everybody. Welcome. How's everyone doing? Happy Monday. I hope everyone's doing well. So yeah, thank you for joining us for our final, the final workshop of the spring semester. So hopefully folks have been checking in with us for the entire time, but in case you're not familiar, basically this workshop series, we have a series of special topics where we have cool guest lectures kind of introducing us to how they use computing research in different domains of interest. So today's goal, or today's topic is how do I combine other interests with computing? And yeah, next slide. So just a quick disclaimer, because this meeting's recorded, just to give everyone a heads up. So this workshop is being recorded and it may be made available for informational and educational purposes only. The CRA does not make any representation or warranties with respect to accuracy, applicability, fitness, or completeness of the contents. The information contained in this workshop represents the views and opinions of individuals and does not necessarily represent the views or opinions of the CRA, the Computing Research Association, or any of the organizations that our speakers or participants are affiliated with. Awesome. So yeah, just to kind of give some folks some context about the series as a whole. Basically, the UART to PhD program, it's a program that the objective is to increase access to undergraduate research opportunities and to close the gap between a student's first experience and a successful PhD application. And specifically, we have a focus on women and gender marginalized folks. And some of the activities of the program include undergraduate research methods course, graduate student mentor training course, and a bunch of online workshops. And for this workshop series specifically, this has been a monthly 1-hour series of workshops designed to help students learn more about computing research, research careers, and graduate education. And so far, this is our 4th workshop. So the other 3 being workshops where, so you've done some research, what's next? What does a career in computing research look like, and how will my research change the world? And then today, as I mentioned, we're talking about how do I combine my interests with my other interests with computing. If any of these sound interesting, but you weren't able to make it to our prior workshops, all of the recordings are available on the CRA website, and we can share that with you at the end of the session. Yeah, I don't know, Christine, if you wanted to.
Oh, yeah. Yeah, sure. So just introduce the team. So thank you, Nima. The team of facilitators and coordinators have been myself and Nima and Julia. And if you ever have any questions about this program or any of its future offerings, knowing that this is the last workshop, please feel free to email us at the email you can see in front of you. We're always happy to answer questions, and there's a lot more that the CRA is offering. Okay, now, to give you a quick summary of what we're doing this session. So this session is about how computing, can fit my interests. So first we're going to start with a quick poll, and then we'll talk about what this session is about. The poll right now is popping up, and please feel free to complete it as I'm finishing up, and walking you through those slides. We're going to start with 2 demos from our 2 awesome speakers who are with us here today, Gilwoo Lee and Mueller, and they are going to present some demos about their awesome work and slides and show us some, little insight into what they do and how computing is, used in their disciplines. And then we'll walk you through a few other examples of how computing can be combined with other interests, and there's a lot of cool integrations that can be done. And we'll transition to an activity where all the participants, everyone here in the session will get together and we'll try and see computing plus what, how can you make computing work for different interests? And then we'll end with what's next and a final survey. All right, so the poll is now in front of you. Please feel free to complete it. We're gonna wait for a minute or so until everyone gets a chance to complete it. You should have a pop-up screen, a screen that just popped up in front of you. Please answer the couple of questions that you have in front of you. The objectives of this session are as follows. So really, we have 2 big objectives for today. One is to have a better understanding of the various ways in which computing can intersect with diverse fields. We wanted to show you that computing is not just sitting down writing code. Yes, it is sitting down writing code, but the applications of that code goes into so many disciplines, so many interests, and you can find it everywhere from cheese making to paleontology. And we also, the other objective of this is to hopefully that you'll be inspired and better equipped to explore how you can merge your interests with your works and computing. All right, so now I'm gonna transition to introducing our 2 awesome guest speakers. Our first guest speaker is Gilwoo Lee, who's the CEO and founder of Zordi. She's at Zordi is a startup that builds autonomous growing solutions with robots and AI to feed the world with high quality, sustainable food. So an amazing application of her work. She holds a PhD from the University of Washington, an MS from Carnegie Mellon University, Master of Engineering, and a bachelor's degree from MIT, and all of them are computer science. She loves solving hard problems that matter and loves seeing robots in action. Our second speaker is Nick Mueller, the co-founder of HD Retrovision. He's an electrical engineer and mathematician who received his undergraduate degrees from the University of Illinois at Urbana-Champaign and graduate degree from the University of California, San Diego, UCSD. He has spent the last 10 years working as a co-founder of HD Retrovision, a two-person operation in the business of helping people get the best video quality out of their retro video game consoles. A very cool application domain. Nick facilitates the design and development of optimized analog and digital circuitry to make old school gaming on modern televisions a reality. Please, thank you so much for our speakers. Welcome. And now I'm gonna, leave the floor. I'm gonna stop sharing my screen, and Gilwoo Lee will be the person who's gonna share the screen. I guess Gilwoo has her slides, demos. Perfect. Please go ahead.
1 second. Can you see the whole screen moving?
Yes.
Perfect.
Yeah. Hi, everyone. Really nice to meet you all. My name is Gilwoo, and I'm building the robotic greenhouses for a climate-resilient future. One thing that might surprise everyone is that fresh produce is the single most volatile category. Depending on what you're buying, they can swing, and where you are, they can swing up to like 457% in terms of price annually. And it's about to get worse. We're entering this era called climateflation. We're expecting 3 times more inflation in food than others by 2035. And mainly because we're going to have a lot of extreme weather events like heat wave, drought, and rainstorms and things like those. So what that really means is that groceries, Walmart and Whole Foods are looking for reliable suppliers, aka indoor farms. Indoor farms is, just for kind of everyone here, is like greenhouses and vertical farms where you're protecting the production from these extreme weather conditions and providing year-round sustainable supply of fresh produce like lettuce, tomatoes, strawberries, and things like those. So wherever possible, indoor farms have made big progress. So for example, if you're in New England, 20% of the packed salads that you get are grown indoors. This was negligible 7 years ago. 37% of tomatoes sold in the US are also greenhouse grown, was negligible in the 1990s. So it looks like, indoor farms should be thriving, right? However, actually, in the recent years, many indoor farms have failed due to high cost. When you're building these indoor farms, you end up spending a lot of money in LEDs, HVAC equipment, and then end up also spending a lot of money in energy costs and labor cost. Not many of these are automated. So this is where our solution, Z-Farm, comes in. We are the first company to marry the lowest cost greenhouses, what's called hoop houses, to optimize the design of the greenhouse for robots and customized plant varieties and the orientations to really make it easy for more automation, and started developing proprietary robots and AI to get to 4 times labor reduction. Now, what that means is that we're able to offer much faster return on investment, which is really the key to get these things hyperscalable. And what's really exciting is that at scale, the cost of production will be competitive with the field, so we can really start hyperscaling and feeding the world. Now, this is what our R&D farm, the first R&D farm, this one has LED lights, mainly because we really wanted to be able to push the R&D side of it, looks like. So you can see here that we have scouting robots that are monitoring these plants every day, and it gets all the pictures gets parsed by our AI to make decisions. And then there's another piece of the robot that's doing harvesting. So it all kind of works together. Now, where we are in terms of our progress, we've already finished the very first Z farm, which is the production version, not the R&D version that you saw. And this picture is showing the production version of it. This facility took us less than 3 months to build. And the scouting robots have been running for remote and enabling us to do more remote management. And you can see here, but basically, AI is making pest and disease management decisions. But you can see here the harvesting robots have been picking about 80% of the berries, which is our target. So with that, and across different lighting conditions, with that, you might be wondering, so what are we actually selling? So the first product is actually the berries, because we want to build and own and operate our own farms, and also to build and scale with our partner franchise farms. So what's been exciting is that the berries that we've been growing and selling, they've been getting really great feedback from our customers. Our berries tend to be very naturally very sweet. We've been selling across different partners, including some of the stores you might have heard of, and we'll be starting to sell to Walmart towards the end of this year. And be getting a lot of, people really love our berries. They're really looking for berries. We're likely going to be sold out for this coming season, even before this coming fall, for new expansion, even before we actually finish the project. What's really exciting about kind of working at a startup or building a startup is that you really get to work with a very different type of people. My co-founder is the head grower. She's a 6th-generation farmer from Cornell, and we really complement each other. And our CTO is also a robotics nerd like me, so we kind of hang well a lot in that way. And we've been backed by amazing investors like Coastal Ventures and Alumni Ventures. And part of my job as a CEO is to continue demonstrating new milestones and convincing more investors to join us as we scale up. So with that, so what we're building is really the future of agriculture, and that's been really the exciting part of the journey. I took robotics and AI, which is what I've learned and researched throughout my PhD, and took that to build a more sustainable future. We are able to build, once we get to scale, this will be the most fascinating thing that brings more sustainable, affordable food to the world. Yeah, I think that's all. Thank you.
That is great. Thank you. Thank you, Gilwoo. So now I'm going to share my screen. All right. Can everyone see my screen? And
yep.
Perfect. Now, Nick, we transition to Nick. Please, thank you so much, Gilwoo, for that great presentation. Your work is very cool. Okay, now, Nick, it's your turn.
Yeah, thank you. That's a tough act to follow. Growing food versus video games. But yeah, my name's Nick. I'm part of a 2-person company that I started with my best friend since high school. We met each other when we were 14 and both went to school for electrical and computer engineering, and took this project from an undergraduate design project to a company that was funded on Kickstarter and now is self-sustaining. So yeah, if you want to go to the next slide. Our passion is old video game consoles, and part of that might be us trying to relive our childhoods, but the other part of that is that those video game consoles just had objectively better games than what you guys play today. There's no question about that, so don't argue with me. But the problem is, we used to play these old video game consoles on CRT TVs, and the fact is those were really good at hiding a lot of the blemishes of the video content. And these days, if you try to take these old consoles and play them on an HD TV, one, sometimes it's just not even compatible, and two, when it is compatible, it may just not look good, and you may want to throw the old console out and move back onto your PlayStation 5. So we wanted to solve that challenge. So if you want to go to the next slide. Yeah. So here's a little slide from an old game called NBA Jam. And the reason it looks terrible, the text is blurry and hard to read, and looks like rainbow colors instead of white, is because the video, even though at the console level is this beautiful, crisp RGB video, to get it to display on those old CRT televisions, it was all compressed down into that single yellow plug. So you don't have to worry about that block diagram, other than to say that you started with very crisp video, and you start merging things and compressing them, and then when you want to display it, you have to undo all of that, and you get a lot of loss. And when you take that image that's there and blow it up to a 75-inch OLED TV, it's going to look terrible. Next slide. So this was the project on the top breadboard there. That was the original project in the undergraduate days. A pretty crazy looking circuit that actually sat on the shelf after school for maybe 8 years or so, until we did realize that millennials now all of a sudden had disposable income and wanted to spend it on reliving their childhoods. So we worked to eventually shrink it down, and you can see a couple of stages there where we took that circuit board and shrunk it and eventually integrated it into a cable that would get you that pure RGB signal out of your console. The nice thing about those old consoles is, even though what you originally put on your TV was terrible looking, you could still actually access that clean signal. You just needed a circuit board to do the right math to display it properly. Next slide. So I wanted to talk about 2 computing challenges that were involved in this project of ours. Taking it, it's one thing to have an undergraduate design project that is on a messy circuit board that looks like spaghetti, but it's another thing to produce a product at a factory in high volume. That becomes a much bigger challenge. So one of the things we had to do was actually write our own test software and put it onto cartridges. So every single console that we developed cables for, we had to write test software for. And 2 examples here are a Sega Genesis and Super Nintendo cartridge. Fortunately, the Sega Genesis had a really nice SDK written in C++. I could do things just like call a function that drew colored rectangles on the screen, and that was super nice. But when it came to Super Nintendo, that was a ground up assembly project, so I had to relearn assembly 10 years after the first time I had done it. Didn't have nice things like even putting font on the screen. I had to write my own functions just to do that. So that was a big headache. But it was important because you need to make the console do what you want it to do. And one of those things is just displaying test patterns. And if you go to the next slide, why do we need those test patterns? Well, it turns out that each one of these consoles had a dozen revisions of circuit boards. They have all sorts of different characteristics. So you need to be able to display test patterns and then take measurements of it. So for example, with the Super Nintendo, depending on when you bought that Super Nintendo, some of them output a signal that's just way too bright and some are way too dark, and we wanted to correct for that in our cable. Another challenge was designing cabling that didn't pass a bunch of noise. So oftentimes with cheap cables, you get the video lines coupling into the audio, and it's just, you get this really annoying 15 kilohertz buzz. So this let us display images on the screen. Turns out just a pure magenta image, but that's like the worst possible video that you could display to generate audio. Now we could take measurements of how good our cables were at getting rid of that buzz. Next. So the other big computing challenge in going to production was when you design this circuit and place hundreds of tiny little components on it, and then you overmold it. Once that process happens, you can't make any changes. So if that cable isn't working, it's going in the garbage. And when you do this on a scale where you're making thousands of these, imagine that one little resistor on there was designed to be a 10 ohm resistor, and they put a 10,000 ohm resistor. The whole cable is scrapped from a little mistake, and you're probably out of business. So we had to design a test fixture that took those little circuit boards and essentially ran that same software that was in the previous slide, but that was run on an FPGA. It runs it through the circuit board, and then on the other end measures the outputs to make sure that it's outputting what you would expect. So that test fixture that's in the top right there, that in itself was a whole project. If you go to the next slide, this was also a computing challenge because you can't, with analog signals, you can't just say, I need this to measure 1.2 volts. That's not how things work. Every resistor, every capacitor, every component on your board has a tolerance. And depending on how tight you want those tolerance, it can make the parts more or less expensive. And when you're talking about hundreds of components, you could have a whole range of outputs that are acceptable. So you need to measure when I feed this known signal in on the input side, what is the range of outputs that I'm willing to accept? And the way you do that is through what's called Monte Carlo simulations. You essentially run thousands of iterations of this circuit design where every time you randomly flip each component to its worst possible value in the positive or negative direction. You run the whole circuit, you take the measurement, and you see where that line ends up, and you get thousands of these, and then you can come up with your range of acceptable outputs. So yeah, that's that. And last slide is that top left image there is the whole setup. You see the cartridge in the console. There's the test fixture there. That was when we got our first Kickstarter batch, and we were actually manually testing to make sure that everything worked okay. And then on the right, you see the difference between the composite image versus what comes out of our cables, and looks real nice when displayed on a high definition TV. Even if you click the demo, you can show a YouTube video. I don't know if that'll work. It's like 30 seconds long. It's not a big deal either way. Yeah, that's just a video of our cable in action. And that's all from me.
Awesome. Thank you so much, Nick. Oh, this is exciting stuff. I mean, I'm sure students that have played around with some retro consoles, or, if your parents have any, I'm sure they've dealt with this struggle of, how do we get them to actually display properly on modern displays? So yeah, thank you, Nick. This is awesome stuff. So before we transition to the examples of interdisciplinary work, we just wanted to have a little bit of a panel Q&A with our two presenters. So I'm gonna put them as spotlights, and I'm gonna put myself and Christina spotlights as well. So a lot of the students are very eager to get into computing research. They might have a little bit of background, and just generally they kind of want to get a feel for what's next. And I think both of your presentations did such an amazing job just showing, what you learn in the classroom, those are not necessarily the only applications of what you could do with computing research. You really apply it to all sorts of fields. But just really quickly, we wanted to just kind of ask you both a few questions about you know, some of your background, some of the context of what got you to where you are today. So I guess maybe my first question, you both mentioned that you have some form of kind of entrepreneurship where you both created startup companies that you kind of have been leading your own business. So I guess for each of you, just what does the daily work life look like for you? What do you do from day to day? Is it mainly coding? Is it mainly getting in the weeds of hardware? Is it, you know, dealing with fruits? So no preference on whichever order, but I guess, you know, maybe to each of you, what does your day-to-day life look like?
You start.
Yeah, sure. So for me, it varies a lot depending on the time of the year or stage of the company. Like for example, right now we are in the middle of fundraising. So what you saw today is like a snippets of things that I share with my investors. I do a lot of biz dev and sales, like with so I organize things with our partner retailers, so like a little bit of that's there, and I do also talk a lot with my CTO or the engineering team. Mostly, I don't really get to code. I did code a little bit in the beginning of the company, but these days it's more like setting the directions, discussing the progress, and seeing what needs to be prioritized. Really, I think the goal of a CEO is to make sure that things are being prioritized correctly, and then making sure that we are planning ahead and also course correcting on the way. So a lot of it is meetings, but the nice thing about, I think, being a technical CEO is that you really get to understand the progress of technical stuff a lot more easily. So you really get to focus on the rest of the business as well, which is more, but sometimes, you know, like a lot more important than just getting the technology right for something like what we're doing.
Yeah,
Awesome.
for me, it's
Yeah, go for it. Sorry. Yeah.
Similar in that like I wear a lot of hats in the company. We didn't take any investment money. This was all kind of started from our own little funding and now sustains itself, but there's still only two of us. There's only always been two. We don't have employees, so I've had to, you know, wear the role of being, you know, the company accountant as well as writing software. So yeah, it's really just a day-to-day thing, what needs to get done. As far as the engineering goes, my co-founder is definitely more on the analog hardware design, whereas I tend to specialize more in the digital image processing. You know, wrote the software for a lot of the consoles. But yeah, we kind of both just do everything and whatever needs to get done.
Awesome. Yeah. So a lot of hats, a lot of juggling. That's really, oh, so it must be such an exciting field, just kind of running your own company. I guess kind of spinning off of that question, you know, what prompted you, what influenced you to make this decision to merge your genuine kind of personal interests with computing rather than just kind of getting a standard 9 to 5 job? I guess, you know, how did you make that decision? Was it an easy decision? What were some of the considerations that you made? And, you know, maybe if we have some future entrepreneurs in the audience, you know, what advice would you have for them about what to consider?
Yeah, I can start. So I think for me, it was really more about what do I like doing and what am I good at doing and how do I want to spend the rest of my life, or at least for the next 10 years. And I've actually tried, and I tell my friends or any other kind of students that I get to talk to, for me, it was really trial and error. Some people know from day one that this is what they want to do, or this is perfectly like fits my life. I tried research interns. I've worked as an engineer before. I worked even as like an investor before, or like a part of an investment firm before. So I knew what I was good at, what I liked doing. And after all that, I decided, okay, I am actually, I like building things and I like taking risks and working with cool people, and also wanted to really bring my two passions, like what I like to do intellectually and what I feel really passionate about.
Yeah, for me, I didn't go directly into this. So I started working the corporate day job for many years, including during the founding of this company. This was actually my side gig. I worked a day job 9 to 5, ate dinner, and then worked on this at night and weekends. But, you know, eventually, I think doing things let me put it this way. I think it's great early in your career to do what it takes to make money and get by and save up, but doing things that just for money at a certain point is not going to be fulfilling, and you're just going to be drudging through it. And at a certain point, you're going to want to do something that you actually care about. And that's what this was.
Awesome. Thank you. So we have a couple of excellent questions in the chat, and actually I'm going to merge them together because they're kind of similar. The question is about, do you think it's possible to break into computing? Wait, where did it go? There we go. To break into computing research or a career in entrepreneurship, or something that relates to advancement of ML, but just a bachelor's degree? Or do you recommend that they take graduate level, that they need a graduate level of education, and or to run your own business? Have you taken any business courses about running a company? So what do they need to learn in order, to be successful and pursue their interest?
Yeah, I can maybe talk about it a little bit. So for those of you who just joined, I have a PhD in computer science. Really, my focus has been in doing machine learning, reinforcement learning, and generally machine learning AI, applying that to robots. So like manipulation and mobile navigation robots. So I have a PhD that kind of helped me convincing investors that I can do this. However, I would say that I don't think you need a PhD these days to really start doing these things in machine learning, especially, or robotics. And typically, I think you have to look at the trend and then how far the industry is. These days, a lot of machine learning stuff are being kind of commoditized, becoming a lot more available, sort of like, maybe. So I think a lot of companies are looking for recent grads that are really good at coding, that are able to integrate these things and learn and start applying. Now, there are things that they definitely require or expect PhDs, as in like they're really doing breakthrough new things. And what's really great about PhD training is really scoping the problems, right? Scoping really very highly uncertain problems and shape them into like research questions and doing data-driven kind of experiments and all of those. But outside of those, there are a lot of still like really fun things that are making breakthroughs, like stuff in machine learning that I don't think you necessarily need a PhD, or like I don't think the companies are necessarily looking for PhDs. Now, I think there's still like a gray area where a lot of them are looking for like a master's. So that's something that you might want to look into, and that's not because master's is like a more senior program, but more because not many bachelor's programs offer a lot of like advanced machine learning course. So even if that really depends on your school, as in like a lot of so if you're able to take all these like research courses or machine learning related courses or robotic courses, I don't think that's like a must, but because not many do have it, then I think they're looking for a master's degree sometimes. Yeah.
Awesome.
Yeah,
thank you.
I only hold a master's. I mean, I think doing a master's in computing can be very helpful, but I think there's almost like a correlation causation problem. The people who tend to do masters are the people who want to keep learning, and I think that's more important than anything. If you're willing to keep learning outside of school, you can really do this without a graduate degree. I spent a lot of time on my own, even after my graduate degree, doing Coursera classes, reading books on the subjects. So I think those things help more so than the schooling. If you can demonstrate that knowledge, you don't have to have that degree.
I like that. Thank you. Thank you. I love the perspectives. And actually it's a nice also segue, so because we had a question in the chat as well, that on what advice do you have for those who are passionate about going into tech but hesitant due to the lack of experience or understanding of the material?
Yeah, so I think if you don't have any educational background in tech, but you feel very passionate about, then you really have to figure out what type of work that you think you can do well in the tech space, because not everybody has to be engineers and still be very meaningful contributors in the tech space. We also have, so for example, in our company, we have two amazing examples where one person, she studied fine arts, but she got interested in kind of front-end engineering. So she took a lot of just like professional courses, and she joined us as this was her first job, like doing a lot of front-end work. So that's kind of, you learned your way without a degree. And the other example is our product manager, where she is fascinating. She's, I believe, studied journalism as an undergrad, and then she's just really great at thorough thinking, understanding the technical requirements, and kind of coordinating between different engineers to get to the right, continue developing the right product that meets the company guideline. And that's, I would say, highly technical as well. You know, whether she writes the code or not doesn't really matter.
Yeah, I think some degree of just willing to get your hands dirty and try things out helps a lot. I mean, I don't have a degree in accounting or a law degree, but I had to do those things. And so I just did them and figured it out along the way. And again, if you're willing to go out there and do the research and look things up online, you can accomplish a lot. It just, I think for a lot of people, getting over that initial step where they didn't have the formal training in something, you just got to remember that doesn't matter. Nobody is checking to make sure that I could understand a legal document, but I had to figure it out.
That's perfect. Thank you so much to both of you. And I feel like there's a consensus here is that you can learn. Like, it's never too late. If there's something you're passionate about, you can just pursue it and keep learning about it, and you'll get there. Thank you. Thank you so much. Very appreciated. So I guess now we will, we'll transition. I mean, thank you for the panelists. Please stay along. I mean, there's going to be more questions probably in the chat. Everyone, please keep asking questions. We're now gonna transition to the computing plus X. If that's okay with everybody.
Can I just say,
sure.
As far as if you had any questions for me that I can't answer here, my email was on one of those slides. You are more than welcome to ask me anything you want. Just wanted to put that out there.
Thank you. Thank you, Nate.
Yeah, thanks. And I think we'll probably transition back to Q&A afterwards too. So
okay, sure.
Great.
So please,
that sounds great.
That'll be great. Thank you. All right. So sharing my screen again.
Awesome. So as Christina mentioned, we got a glimpse of just a couple different interest areas that you could potentially intersect your interests with computing research. And I think for the rest of this workshop, we really want each of you to kind of be introspective and think about what exactly is it that you are personally passionate about. It could be some world problem that you want to solve. It could be some hobby that you're just really passionate about. It could be some subject you're interested in. So we're going to have a, not really rapid fire, but semi-rapid fire, just a bunch of different areas that we thought were really cool intersections of computing with some other discipline. This is by no means comprehensive. And I think the more that you look into this, you're going to go down this super deep rabbit hole of just all the amazing things that you can do. But yeah, we'll just kind of go through. So the first example that we have is kind of this intersection with computing and art. And I'm sure everyone here has kind of been experiencing this craze with generative AI. I don't know if folks have been using DALL-E or similar tools, but there's this interesting kind of intersection between artificial intelligence and artwork, where maybe you can train some AI model based on all of these different existing artworks, and then create a tool that you can then prompt, or that can somehow generate new art that's motivated by or inspired by real art. So in this example, this is a technique known as outpainting. So on the top right corner, there's this famous painting, Girl with a Pearl Earring. And the painting was just a portrait of the lady. And then this generative AI model was actually able to do what's called outpainting, where it tries to kind of, not predictively, because it's just making stuff up, but just creating additional art, kind of expanding on the boundaries of this original artwork, kind of completely on its own. So yeah, the world of intersecting art with AI or other forms of computing has just really revolutionized over the past couple of years. Another domain that we want to talk about is, art. We're kind of talking about, things that look nice or kind of things that are artistic, but even other social sciences. We can talk about history and kind of archaeology and how did the Earth look like hundreds of years, like millions or billions of years ago? How did the Earth look like? What was roaming the Earth? So one specific domain is computing mixed with paleontology, where, we didn't get to see the dinosaurs, but we can find some of their skeletons from these fossils that we find around the world. And we can use computer models to study the skeletons and try to predict what did the muscle movements of ancient dinosaurs probably look like from those collected bones. So even though we can't perfectly recapitulate what the world looked like, maybe we can at least understand how those dinosaurs function and maybe predict what they might have looked like or how they might have moved or all those sorts of things. Another domain that this is, I'm a big gamer. So, I love playing modern games. And I think gaming is really one intersection that people kind of take for granted, but there's a lot of crazy computing research that goes behind modern games. So here, this is actually a side-by-side screenshot of an Unreal Engine. So Unreal Engine, this is a game engine. The left side is the video game version, and the right side is the actual photo of the actor, where, if you just showed me both pictures, I wouldn't be able to tell the difference. So, there's been a big revolution about things like how do we do real-time rendering of photorealistic lighting, photorealistic texture. So like, how do we make the skin look real? Photorealistic character models, all sorts of things. And I think with games especially, I really want to highlight the importance of efficiency. So when you're playing a game, you might have heard terms like 60 FPS or 120 FPS or whatever. So what does 60 FPS mean? So 60 frames per second, your computer is generating 60 frames of image every second. Or if you're dealing with 120 FPS, 120 images per second. And on modern displays, maybe you're dealing with like 4K resolution. So not only do we have to have these really complex computational models and these really cool methods of creating these realistic images, but you have to do it many, many, many times per second. So there's like the mathematical modeling side of things, there's the efficiency side of things, and you want the gamer to be able to immerse themselves without having frames get dropped or feeling slow down or anything like that. So a lot of crazy engineering goes behind that as well. And then the next one, so I don't know if anyone here is a basketball fan, but you can actually intersect computing with different sports. So this screenshot here, this is actually one of my colleagues for my PhD program. I have a PhD in bioinformatics, and one of my colleagues was also doing bioinformatics, but in undergrad was a basketball player on the UC San Diego basketball team. And she was really interested in intersecting her basketball passion with computing. And she actually did a lot of work coming up with machine learning based kind of data driven methods for how do you maximize the chances of making 3-point shots. And actually the work that she did was picked up by Stephen Curry, and he actually used it to try to improve his own 3-point game. So, how do we train machine learning models that can predict based on where you're located and based on the arc and kind of all sorts of different factors? How do you maximize your chances of succeeding in whatever sport that you're playing? Another domain, computing and health. So I'm sure everyone has been impacted by the COVID-19 pandemic in some way. And in general, there's all sorts of diseases like cancer, HIV, diabetes, all sorts of diseases that people have to live with. And ideally, we want to come up with therapeutics to help at least, hopefully cure some of these diseases, or hopefully at least treat them so that they're manageable. So computational tools have been very powerful in predicting the 3-dimensional structure of proteins that we can then use things called molecular dynamic simulations to try to predict how effective potential therapeutics could be. So it can help medical researchers discover and even potentially design novel therapeutics to better treat diseases. Yeah, and then one other one that I'm going to talk about. So in behavioral economics, we're trying to study, how do people behave and like what are their actions going to look like? And you can actually come up with computational models where these are called, basically agent-based models, ABMs, that you can treat each individual person in a population as some entity in this computational model. And you can try to simulate how are the people going to interact with each other, how they're going to interact with their environment. And the use of these, you can try to see like what are the effects of market sentiment, or can we predict what's going to happen with prices or what's going to happen just in the economy. So you want to be able to model these things accurately, but then also run tons and tons of simulations efficiently to make interesting insights.
Awesome. And also to give you a little bit of insight, like there's so many intersections of computing with different things. One, for example, over here is, computing with fashion. And we wanted to show you that there's a lot of work that's being done on that front, things that you actually sometimes use on a daily basis. And we wanted to show you here two pieces of work. One of them is the one on the left here that you see, which is about Amazon Shop the Look, just to show you that even if you were, you're working as part of industry, so that's actually a paper published by developers at Amazon. They do research within the company in order to produce the different features that you see on like every now and then. All of these new features involve tons of research. They involve a lot of computation. And then sometimes they end up with cool products like Shop the Look. And also on the right side, I wanted to show some other examples of web search of fashion items with multimodal querying. The reason I wanted to show this paper is to show you that it was from 2018, so that you don't think that all the hype in AI and machine learning just happened like 2 years ago. That's when we all started hearing about AI and machine learning. But like, no, AI and machine learning, they've always been part of computing. We've always been using those models for so long. It's just that now we have a lot of more data, so it's getting cooler and cooler. But yeah, you could use machine learning and AI to find, search for similar items and prioritize and just personalize search queries and search results based on the user preferences. One more interesting intersection. I love cheese, so it was so cool for me when I found this. It's like computing and cheese. So you can use, actually over here, you can replace cheese with any type of food you want. You'd be surprised. You just go do a Google search and say computing, research, plus, and then add any kind of food that you would like. We use computing in so many different ways in order to understand whether the food is ripe, food is ready. I mean, we have our presenter today talking about how computing is used for farming. So like, I don't think I need to motivate this much more. But yeah, for cheese, it's been used for years and years and years, for many decades now. Computer vision has been used to detect the age of cheese and whether cheese is ripe enough and ready for production of being sold or not. It's also used in so many different things. I mean, last but not least in our slides, like, so just to, so we can get to the activity, wanted to show you just one more thing, computing plus archival maps. So if you're someone who's interested in history, who loves archival maps, archival texts, this is just a snippet on some of the work that's being done by computer scientists on how to understand archival maps, how to translate them, how to take something visual at different scopes and different levels and different different perspectives to understand historical map collection and how land evolved over time. And then on the right hand side over here, you can see some samples on how old archival maps, no matter how high quality you are, you would think that this is amazing and high quality, but when you take this and give it to a computer, the computer would still go and nitpick on every single pixel in those maps. And how can you train the computer? How can you train a piece of software to really read those maps as a human would read them, and teach the computer that something like figure A over here, so on the left-hand side, sorry, this is what, right-hand side, the leftmost image on the right-hand side, figure A, how to train the computer not to translate those blue little dots into water, and it's just discoloration from the age of the map. A lot of cool stuff that are being done in that field. And so many of them, some of them are older, some of them are still recent. So this last one, the paper on where you see the images from the right-hand side, came from a paper from 2023. So there's still a lot of work that is being done in that field, in that area. All right, with that, we transition to the activity. So let's just tell you very quickly what this activity is going to be about. We're going to break you up into breakout rooms. And your goal is to, number one, meet other people who attended the session. So get to chat with the people around you. Like, feel free to unmute yourself and actually talk to the other people with you in the panel. Sorry, not the panel. I mean, in the meeting and the workshop. And articulate your interests. So I'd like you to do some thinking. I mean, we've asked you a couple of times, if you've noticed, what is your hobby? What is your interest? What is something that you think is not related to computing? So it would be great if you feel comfortable sharing that. That would be the thing that the group will be talking about. And then start thinking about how you can take those passions and those things that you're interested in and move them and turn them into something that can turn it into a product, turn it into a research area, turn it into something where you can really apply your computing skills to. Sounds good? All right, are we going to be around for any questions? So breakout rooms are being created right now. I'm going to stop the sharing so that you can chat.
Welcome back, everybody. Welcome back. I hope everyone had some fun conversations about your hobbies, your interests, all that good stuff. So we only have a couple minutes left. We wanted to reserve the last 2 or so minutes just in case anyone had any like last questions that maybe some of that communication might have spurred. Any last questions for our speakers or anything? Feel free to type in the chat. I know that it's been a long day, so no worries if not.
I do recall seeing one in the chat about whether or not to care about money first or not. Which
You want to take that one? Yeah, go for it.
I'm happy to take that one.
Yeah.
I think well, 2 points on this. When you're young, go do the fun things, because your life gets exponentially more complicated, especially once you hit your 30s. Maybe you have pets, maybe you have kids, maybe you have a mortgage. I went to Singapore for a year after I graduated from UCSD. Wouldn't be able to do that right now, just off the table. So those fun things you may want to do early on, but I would say that getting your finances and money straight, once you've done those things, is also something you want to do early on. It makes your life simpler as you get older and lets you do something like go all in on your own project. So I think there's nothing wrong with like taking that high-paying FANG job out of school and making good money and having good health insurance and saving, scrapping by, living with roommates, doing all that stuff for 5-10 years, and then taking a jump at entrepreneurship. Of course, you can go the other route and get VC funding and become a millionaire, but not all of us can do that with our project. So that's just my take on it.
Awesome. Yeah, thank you. I definitely echo all of that. I mean, stability is always a nice thing to have. Money doesn't solve all the problems, but it solves a lot of problems.
Yeah.
Awesome. Well, yeah, thank you so much, Nick. And I'm not sure if Gilwoo is still on, but thank you to her as well. Thanks everyone for coming. So we're just going to wrap up. Christine's going to share the slides again. So what's next for this workshop series? Hopefully you enjoyed the previous ones. Hopefully you enjoyed this one. So one of the goals of the UR to PhD program is to increase the quality and scale of undergraduate research. And some of our program activities basically focused on expanding capacity is we want to have this undergraduate research methods course where you're going to actually learn how do you conduct research day to day, what are some of the technical skills that you need, all that good stuff. And we'll also have a graduate student mentor training course. Oh, and by the way, so blue indicates programming for undergraduate students, and then green is for graduate students. And then for increasing retention, we have these research engagement and awareness workshops. This is one of them. And we also have a graduate admissions preparation workshop. So as you noticed, this one, we kind of alluded to some kind of grad schooly or career life type of stuff. But then if you want to just see like specific, how do I get into grad school? What are the steps? What do I need to do? Those other workshops might be helpful as well. Yeah, so just a general structure of what's going on. So in the summer, we're going to have the research methods course. Applications are open. We have a bunch of stuff here, so I won't read all of them. You can kind of take a look. But just generally, I'm just going to highlight that if you go to the cra.org/UR to PhD website, we have all these resources there. We have all the recordings from this session, prior sessions, everything is over there. And we really hope that we'll see you in our future events. And then, yeah, so just kind of summary. So summer undergraduate research methods course is eligible. Any undergraduates working in groups of 2 to 4 on the same computing related project under the supervision of a faculty mentor who are able to attend all the entire course. And why participate? You can get you can acquire and practice some fundamental research skills, and you can build a community of peers across the nation, which is a pretty cool thing. I mean, even just us, like Christine, Nick, and I, and Julia, we're all over the world, not all over the world, all over the country. So it's kind of cool getting this kind of cross-nation kind of community. When is it? We have session A from May 20th to June 13th, and then session B, June 17th is July 15th. And the application is on the CRA website, UR to PhD. Awesome. So yeah, and as always, where can you find more information? I'm going to keep pointing you to the CRA UR to PhD website. tons of great stuff on there. So definitely check that out. Awesome. So yeah, so you know, we have a survey for you all. It shouldn't take more than 10 minutes. Please, if you could, we would appreciate it if you filled it out. We want to make these sessions better for you. We want to make them better for future students. So your feedback is immensely helpful to us for improving. So yeah, so once this meeting ends, it's going to automatically launch in your browser.
Yep, agreed. Thank you so much.
Yeah, thanks so much, everyone. Thank you,
Thank
Nick, and thank you, Gilwoo.
Yeah.
This was excellent. We really
Thank
enjoyed
you.
hearing from you all.
Thank you so much. Really, thank you everyone for being part of this, and hopefully we'll see you in the fall. Thank you so much, Nick.
Awesome. Thanks, everybody.
Thank you.
Bye, everyone.
Bye, everybody.